This lesson is about the key features of quadratic graphs. One key feature is concavity. This is concavity. Concavity is whether the graph opens up or down. So quadratic graphs are parabolas. They make this U shape. If the concavity, this is standard form right here. If the a, or the coefficient in front of x squared, which is this, is positive, the graph opens up. If the a is negative, it opens down. If it opens up, then this graph has a minimum value. Its vertex is a minimum value. If it opens down, its vertex is a maximum value. Another key feature is the vertex. The vertex is either the low point, minimum, or the high point, maximum, of this U shape. So this graph has a vertex at 3, 1. This is the vertex right here. Quadratic graphs have an axis of symmetry. An axis is a line. Like the earth rotates around an axis. That's a line, an axis. So it's called a line of symmetry or an axis of symmetry. But you always need to answer this question in the form of a line. So for our picture, right here, this is the axis of symmetry, or line of symmetry. And you write it, x equals 3. Another feature of graphs is these graphs have a maximum or a minimum value. We've already talked about this. This is always the vertex. If the graph opens down, then the graph has a high point or a maximum. If the graph opens up, then the graph has a minimum or a low point. Some quadratic graphs have x-intercepts. X-intercepts are the places where the graph crosses the x-axis or touches the x-axis. It can look like this. -3, 0. This is how you label them. You label them as an ordered pair. An x-intercept could also look like this, where it would just touch once. So this would be -3, 0. That would be another way x-intercept, if it just touches the x-axis. Quadratic graphs can also have a y-intercept. A y-intercept happens when you set x equal to 0. When x is set equal to 0, and you put it in for the equation, that's where the y value, it gives you the y value. So here is my y-intercept. This is where the graph touches the y-axis. Okay, domain and range. Domain are the x values. It can also be called the input of the function. Domain is always right here. This is what you're talking about. The furthest left in the x-axis is called -infinity. The furthest right is called infinity. Anytime you're asking about the domain of quadratic graphs, you can put in any x value, which is called, you can put in all real numbers. This is the way that you can show this in interval notation. -infinity to infinity, and that means all the numbers between -infinity and infinity. Okay, range. Range is the y values. Range is talking about the y values. Whenever I think about this, instead of going left to right, now range is low to high because range is y, the y values. And you always talk about it low to high, or you talk about your interval low to high. When you're talking about range, you always include the lowest number if it's a number. And in this case, our lowest y value was 1. So 1, and then you go up as high as you can, and this is called positive infinity, when you go up as high as you can. Okay, the final thing I'm going to talk about is increasing and decreasing. Well, when you're talking about increasing of a graph, it's when the graph is increasing. You always look at a graph from left to right, like you read a book from left to right. So if I'm looking at this graph, and I think about when it's increasing, this graph is increasing where I colored in orange. That's where it's increasing. From left to right, it's like walking up a hill. I'm walking up the hill. It's increasing. The slope is increasing. So when you talk about increasing, you look at what y is doing, but you always answer these questions with x values. So this right here is where it's increasing. You talk about the x values. So the x values are from 3 to infinity. You make the brackets curvy brackets. You don't include 3. 3 is really called a point of inflection. It's where it changes. And so you don't include 3. 3 is the point where it changes. When you talk about decreasing from left to right, decreasing is where you're going down the hill, or you're running down the hill. Red, where I colored in red, is where it's decreasing. So you look at y, where it's coming down the hill, but you answer the question for decreasing with x values. So here's the x values. And you always go from left to right. Left is negative infinity down here. Negative infinity to 3. All right, that's it. Hopefully you got that.